purpose of this video is to introduce you to the idea of graphing sine and cosine functions. So there's a lot of vocabulary you're going to be learning today, and we are going to use the unit circle to help us out. So we know something about sine and cosine already. Sine, we know, is the y value. Cosine is the x value. So as I'm filling out this table right here, theta is right here, and I need to know what is sine of theta. So what is sine of 0? Well, I'm going to pull out my unit circle. At 0, sine is 0 because that's the y value. At pi over 6, what is sine? So again, looking at the y value, sine would be a positive 1/2. And I'm going to keep using my unit circle to fill out this table. So feel free to pause the video and grab your unit circle, and you can check my work as I go through it, but I'm just going to fill out this table while looking at it. Pi over 4, sine is a positive root 2 over 2. Pi over 3, root 3 over 2. Pi over 2, a quadrantal angle, sine is 1. And then 2 pi over 3 is root 3 over 2. And it's positive because it's in quadrant 2. Then root 2 over 2, 1/2. Pi, quadrantal angle, is 0. And now in quadrant 3, the sine values are going to be negative. So negative 1/2, negative root 2 over 2, negative root 3 over 2. And then this right here is a quadrantal angle where the sine value is negative 1. Then all this right here, these three angles are quadrant 4, so it's still going to be negative. Negative root 3 over 2, negative root 2 over 2, negative 1/2, and then 0. Again, what I was doing was I was just taking a look at the unit circle, and for each measure, for each angle, I was looking at the y value. And then same thing when we do cosine is we're going to look at the unit circle and do the x value. So I'm going to go ahead and do it while we still have our unit circle out. Cosine of 0, the x value is 1. Keep it out, we're going to keep doing that. See, in quadrant 1, which is these three right here, cosine's positive, so it's going to be root 3 over 2, root 2 over 2, 1/2. This is a quadrantal angle where x is 0. Now in quadrant 2, my special angles are going to be negative for the x values, so negative 1/2. Negative root 2 over 2, negative root 3 over 2. Then this right here is a quadrantal angle where the x value is negative 1. This is quadrant 3 where the x value is still negative, so it's negative root 3 over 2, negative root 2 over 2, negative 1/2. And this is a quadrantal angle where x was 0, 1/2, root 2 over 2, root 3 over 2, 1, because these were in quadrant 4, which has positive x values. Okay, so once again, I just used my unit circle to fill those in. And I used the fact that sine was y and cosine was x. Now, what we're going to do is we're going to take a look at what sine and cosine looks like. For each of these, we're going to be graphing the parent function. We talked about this term all the way back in chapter 1 when we first started algebra 2. So a parent function is basically a function before any transformations take place. So my parent function we're going to start off with is sine of x, and all I'm going to do is I'm going to plot my points from this table onto my coordinate plane. If you take a look, you can see that each line on my y-axis is half of a unit, and you can see per 2 tally marks I have a scale going by pi over 6s. So make sure you pay attention to the scale as I go through this. And I'm just going to plot the ones I know. So 0, 0 is right here. Pi over 6 is 1/2. Pi over 4 is root 2 over 2. I don't know exactly what that is. It's approximately 0.7, so I'm not even going to worry about plotting this. Same with when I see root 3 over 2. It is approximately 0.9. So if you wanted to put points there, you could. I'm just going to go through this quickly. So now I see pi over 2, 1. So here's pi over 2. Here's 1. 5 pi over 6, 1/2, which is right here. Pi 0. 7 pi over 6, negative 1/2. 3 pi over 2, negative 1. 11 pi over 6 is negative 1/2, and 2 pi is 0. So I just plotted the points that had 0, 1/2, and 1 as the y values, just to make it really simple. That's enough points to kind of see the shape of the graph. As you're connecting your points, do your best to draw a smooth curve, okay? Sine and cosine will have smooth curves for their shapes. What we see here is one cycle of sine. A full cycle of sine has 5 key points. One of them is at the origin. The next point will be a maximum. The next key point will be an intercept. The next key point will be a minimum. And the 5th key point would be the full period length, so another intercept. These occur at 0, 1/4 of the cycle, which we call a period. This 3rd key point is at 1/2 of the period. This 4th key point is at 3/4 of the period. And then this right here, our last key point, is the full period length. So this full period length, you can see we went from 0 all the way to 2 pi. So the period is 2 pi. Again, a period is the length of the cycle. In fact, it might do us some good to write that. The period is the length of the cycle. Another term you need to know is amplitude. Amplitude is half the difference between the max, which we denote capital M, and the minimum, which we denote lower m values. The amplitude is always positive. So when you see me talk about it in future notes, I'll say A is taking the absolute value of. Now, the amplitude is half the distance between the max and the min, or it's the distance between the line of symmetry and a max or min. So when I look at this graph right here, my line of symmetry is the x-axis. Okay, my line of symmetry is the x-axis. So from the x-axis to a max or a min, it could go either way. I'm just going to do the max. That distance right there is 1. So the amplitude is 1. Or you could think of it this way. The distance to the max and min, so we went up 1 and down 1. That's a total distance of 2. And half of 2 is 1. Now, the domain of the sine or cosine will always be all real numbers. So what happens is this is only one cycle of sine. It's going to continue this pattern, and it's going to do something called oscillating. So it will forever repeat this pattern and bounce between the maximum and minimum. Again, a maximum is denoted with a capital M, and my maximum in this case is 1. A maximum is just the highest point on the graph. A minimum is the lowest point on a graph. So here, my minimum is -1. So when I'm talking about the values it's oscillating between, its lowest point is -1, its highest point is 1, and it's going to keep going back and forth between those. So that impacts the range. The range must always be read down to up. So I'm going to put the value of the minimum and then the value of the maximum. So it's always going to bounce between -1 and 1. All right, time to talk about cosine. Cosine also has 5 key points, but it has a different pattern. So cosine's pattern is going to be max, because I have a point at 0, 1. And then it's going to cross the x-axis at pi/2. Min at -1, cross the x-axis at 3pi/2, and then max at 2pi. So the pattern is max, x-axis, min, x-axis, max. You can see that through the table that we have created from the unit circle. When I'm connecting my points, I'm going to do a nice smooth curve. These 5 key points occur at the same key points we had for sine. It's at 0, 1/4 of the period length, 1/2 of the period length, 3/4 of the period length, and then the full period length. So this full period for cosine, the parent function of cosine, is 2pi. And we can see 1/4 of 2pi is pi/2, half of 2pi is pi, and 3/4 of 2pi is 3pi/2. So you can just check and make sure that that all works. Next, the amplitude. The amplitude is half of the distance between the max, which is at 1, and the min, which is at -1. Remember, there's 2 ways you can think about it. If it's halfway between, it's from the line of symmetry to the max or min. So in this case, that's 0 to 1 or 1. Or you could think of it as distances. So we travel the distance of 1 to the max and the distance of 1 to the min. So 1 plus 1 is 2, divided by 2 is 1, because that's half of the total distance traveled. Just like sine, this pattern is going to continue forever. It's going to repeat over and over and over again. So it's oscillating, okay, bouncing back and forth between the max and the min. This impacts the domain and the range. So because I'm going to keep going on and on and on forever, the x values are not restricted. It's going to be all real numbers. However, the range is impacted because it's bouncing back and forth, and we need to do lowest to highest, or minimum to maximum, which is -1 to 1. Once again, I want to reiterate the patterns. So for sine, the pattern is the origin, max, x-axis, min, x-axis. For cosine, it's max, x-axis, min, x-axis, max. So we have 2 maximums and 1 minimum in cosine, and then 1 max and 1 min in sine. Since this was just an introduction and a way for you to get familiarized with the terminology and the parent functions, I'm not going to give you homework today, but if you have time, I would like you to get started on the next task, just to make sure that you're comfortable with it before I see you next.